We're in the meeting, this fucker. Can you hear me?
Yeah, I finally made it here. Okay. How y'all doing today? I hope your week has gone better than mine. It's only Wednesday. Here we go. Yeah, okay. Yeah. Let's have everybody put their names in the chat. Turn your videos on if you can. Here we go. I'm trying to get my windows set up. Oh, wrong button. There we go. Yeah. I hope. Let me see. Okay. Yeah, turn your video on, pin my screen, and put full name in chat. Those are 3 basic requirements I have. Let me see what I'm doing here. There we go. All right. Any questions for me? Yeah, I don't have my lab up and running yet. I do have the video from Monday in a chat stream. I mean, in a YouTube channel, and I need to post that channel in the what do you call it? In the announcements, so you can have access to it. Let me see. Let me see. I might be able to. No. Nope. Is this it? Nope. Still pre-calculus. Nope. Wrong section. Nope. 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 I'm having a hard time finding it. So this is it. Okay. 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 Oops, there it is. There we go. Yeah, I did all that just to do this. Boom. That should be the channel. Please let me know if it's for your section. It should say college algebra with 031 after it for this section of college algebra. So if you click that, it should pull up the does it? Yeah, it should pull that up. Let me know if it does that for you, and then I'll go ahead and get started. Okay, I'm not 100% sure, but I think this is where we're either this slide or pretty close to it is where we're at. Determine if, well, we determined if these are functions based on the fact, do the X values repeat with different Y values? So if the X value repeats, it should repeat with the same Y value, but the ones that don't, that repeat, but have different Y values, like on letter C, -5 shows up twice as an X value, and the Y values are different. So that makes it not a function. It still has a domain and range. It's just not a function. And then we talk about is this a function? Well, it's a function because it doesn't matter what I put in for X, I get only one y value for that particular x value. So the x values don't go to two different y values. Okay. And this is an example of a linear function. All right, to determine if this is a linear function, if this is a function or not, it's not linear because not all the exponents are 1. Then I need to go in and solve for y. So we subtract 6x from both sides and then divide by 3. So they divided the 2 by 3 and they divided the 6 by 3. That's how they got the 3, the 2/3 minus 2x. And then they take the square root of both sides. Something happens when you take the square root and it's not there to begin with. You have to throw in the plus or minus because when write it this way, when x squared equals 4 and I take the square root, then I'm talking about plus or minus the square root of 4, which gives me a 2 or a -2, because 2 squared is 4 and -2 squared is 4. All right. So that's why we throw in the plus or minus symbol there, because we get 2 answers. So since we get 2 answers, one's positive and the other one's negative, then that means it is not a function. Now x has to be greater than or equal to 1/3, and the reason say x strictly greater than 1/3 gives us 2 values, because if it did equal 1/3, then what's in here goes to 0, and the square root is 0, 0. It has a unique square root, so it only gives us one value. But any other value we put in for x will end up getting 2 square roots. One's positive and the other's negative. Okay, so and they threw in 0, so 0 makes this the square root of 2/3, but it's plus or minus square root of 2/3. So you have the positive square root of 2/3 and the negative square root of 2/3 as your answer. 2 answers from the same one x value. Which does not happen for functions. Okay. So that means that expression does not define a function. Now we have function notation. Function notation, get rid of this. Function notation is just another way of writing y. Okay. And it has several uses. Y equals f of x. So using the f of x is just the same as using y. So if I have y equals 3x minus 2, then I could write this as f of x equals 3x minus 2. One of the advantages of doing this is it gives this function a name. I could have another function. I'm going to call it g. G of x equals x squared minus 5. So if I have both of these functions I'm dealing with, I can talk about the g function and I can talk about the f function without going through the specifics of telling us what those things are. Okay, it's just easier or quicker to refer to the f function and the g function. And so I'm going to say I want to do f of x plus g of x. So that means I'm just going to add the two functions together. Or I'm going to subtract one from the other one, or I'm going to multiply the two together. So I just talk about f of x being multiplied by g of x. So I would put parentheses around the two and do binomial multiplication. Okay, so that's one reason why we use this notation. Another reason why we use this notation is what am I doing here? All right, so well, is if I want to evaluate this function at a specific value, and we'll get to that in a moment. When a function is expressed this way, we say we're using function notation. Now, we refer to f of x as the value of the function at the number x. So we can, if I do f of x and I do it at 1, so when I put 1 in for x, I get 3 minus 2, which is 1. So at 1, f of x is 1. Or 1 is the value of f at the number 1. Let me use a different number. Let's say 2. At 2, we get 4 because we get 3 times 2, 6. 6 minus 2 is 4. So the value of f of f, the value of f is 4 at x equal to 3, or x equal to 2, sorry. So this is how one way of looking at what this means to us. So we get the value of the function. The value of the function is the y value. And x gives us that y value. We can't have the y value without the x. So we have to mention the x that gives us that y value. 2x minus 5 using function notation, f of x equals 2x minus 5. Then f of 1 equals a negative 3. That means if I put 1 in for x, I get negative 3 for the y value. So that would be the point 1, negative 3. So that's the coordinate pair, x and y. If I put 3 in for x, then I get the number 1 back. So the value of the function is 1, where at x equals to 3. Here, the value of the function is negative 3 at x equal to 1. All right, functions. Some of y'all had may have had high school teachers, math teachers, who used the talked about the function model for a function, where you have the input and then the function does something to it like a machine, and it has an output, which is the y value. Now, for each x value, you get a certain y value. If I put that, and doesn't matter how many times I put that x value through the machine, I get the same y value back. Okay. But other values of x might give me the same x value. I mean, the same y value. That's like in my g function here. If I put negative 2 in for x and I put 2 in for x, I'll get the same answer. I'll get the same y value. They both will give me negative 1. because 2 squared is 4, and 4 minus 5 is -1. -2 being squared is 4, and 4 minus 5 is a -1. So I could have two different x values or more giving me the same y value, but I can't have the same y value being paired with different x values for it to be a function. So if you already know it's a function, you know that 2 will only give you a one number. It won't give you two or more different numbers. That doesn't mean that that number you get is unique to 2. Sometimes it is, sometimes it is not. The ones where it is a unique value to that x input, then that's a type of function we call a one-to-one function. And certain things happen with one-to-one functions. We'll discuss that right before we get into logarithms and exponents. Restrictions on this input-output device. It accepts only numbers from the domain. So I can only put numbers in that function that are in the domain. If it's not in the domain, the function isn't going to work. I either get something that isn't in the real numbers, because we primarily deal with the real numbers, or we get something that's undefined, like you end up dividing by 0. Okay. For each input, there's exactly one output, which may be repeated for different inputs. And that's what I was talking about up here with the 2 and -2. Okay, so this is true of all functions. You can only use the numbers from the domain, otherwise the machine blows up in your face. And each input, there's exactly one output. You won't get two or more different numbers for that same input. But more numbers, more inputs might put out the same output. So for the function y equals 2 or f of x equals 2, it doesn't matter what number I put in for x, I'm going to get a 2. Because is there an x in this expression over here? Do you see an x there? Yes or no? Okay. So it's not going to affect, this is called a constant function because it stays the same number. It's constant. So whenever you have a constant function, doesn't matter what the x value is, you're going to get the same y value. So this is a horizontal line where all the y values are 2, but all the x values are different. Okay. So we have independent variables and dependent variables. X is called the independent variable because it does not depend upon another number to happen. Okay, we either choose that number, we say we're starting with this number, or we're going to what is it? We just input different numbers, or we have a method for putting in the numbers, but what numbers we choose to put in is totally arbitrary. So that's why they're independent. Now, the number we get out in the range is called the dependent variable because it depends upon which x we put in. Okay. So getting it in this problem here, getting a -1 is dependent upon putting in -2 or +2 into the function. So I can't talk about -1 being a value of the function unless I talk about which x value I'm using to get it. Okay. So the independent variable is sometimes referred to as the argument. I will very often, especially when we're dealing with exponential and logarithmic functions, talk about the argument of the logarithm or the argument of the exponential. The argument of a function is the value you put in for x or the x. Sometimes the argument is another expression. So if I have a situation where I'm talking about, I want to find out what f of x plus 3 is. So x plus 3 becomes the argument. So I replace my old x with x plus 3 in the function. And so now my argument is x plus 3. Now here we have a function. And we want to evaluate this function at certain values. That's another advantage of having the function notation, where f of 2 means I'm going to replace x with the number 2. So this becomes 2 times 2 times 2 squared minus 5 times 2. And that happens to give us a negative 2. Because 2 squared is 4, and 4 times 2 is 8, and then 5 times 2, negative 5 times 2 is a negative 10. So 5 minus 10 is a negative 2. And that means we have the ordered pair 2, negative 2. Negative 2 as an input gives 2 as an input gives us negative 2 as an output. So the value of the function at 2 is negative 2. That's one way of stating this. Letter B, you got to be careful of what they're asking for. To start with, they're asking for the function, and then we're going to add f of 2 to that. The function itself is 2x squared minus 5x. And then we found out what f of 2 was. F of 2 was negative 2. So this is going to be plus a negative 2. And then simplifying this is 2x squared minus 5x minus 2. Questions? Did y'all see what I was doing there? And if I could see your faces, I could see nodding heads. And everybody went blank on me. Okay. This is why I like to have y'all turn your video on. All right. Now, letter C. This was B and this was A. So letter C, we're going to do 2 times f of x. That means we do 2 times the expression 2x squared minus 5x. All right. So we're going to do the distributive property. This is not just 2 times 2x squared. This is 2 times 2x squared minus 2 times 5x. So that gives us 4x squared minus 10x. Okay. Letter D is something similar, but, oh no, it isn't. Letter D isn't like. Letter D, we're doing f of negative x. So when you're replacing x with an expression, you need to be careful, especially if you're dealing with exponents. So this becomes 2 times the expression negative x squared. So I'm squaring the negative x, not just x, but I'm also squaring the negative. And then I'm subtracting 5 times negative x. Okay. What is negative x squared? It's an important, very important concept here. What happens when you square a negative number?
It becomes positive.
It becomes positive. So this becomes 2x squared because this negative x being squared is just 2x. I mean, just x squared. And so now I have 2x squared. And then a negative 5 times a negative x is plus 5x because negative times negative is positive. So it becomes plus. Now, letter E, we still have a negative sign, but it's not inside the function. It's outside. Whoops. It's outside the function. Just like on letter C, I multiplied the expression by 2. Here, I'm taking the negative of the expression, 2x squared minus 5x. So this is like multiplying by -1. So I'm going to do the distributive property with the negative. So I multiply each of these by the negative, which means I'm just changing their signs. So the 2x squared becomes a negative 2x squared, and the minus 5x becomes a plus 5x. Boom. Please notice this was f of negative x, where this was the negative of f of x. Here, only one sign changed, but here both signs changed. Sometimes both signs will change and sometimes no signs will change. So it just all depends upon what's happening inside the functions. You have, we have special names for certain functions where if you put in negative x and every sign changes, we call those a certain thing, odd functions. And if you put in a negative x and the function doesn't change at all, all the signs remain the same, then we call that an even function. And we'll deal with those a little bit later. Okay. And so now f, letter F, we have f of 2x. All right. Up here on letter C, we multiply the function by 2. Here, we're multiplying the x before we do the function. So that means instead of x being squared and multiplied by 2, it's 2x that's going to be squared and multiplied by 2. And then we're going to subtract 5 times the 2x. Well, what's 2x squared? What's 2x squared? Can someone tell me what 2x squared is?
4x.
4x. Well, you forgot the square on the x, but yeah, 4x squared. So now we have 2 times 4x squared because I'm still multiplying it by 2 out here. So I'm just going to square the 2x and then multiply it by 2. And then I have a minus 5 times 2, which is a minus 10x. And then the 2 times the 4x squared is an 8x squared. And we still have the minus 10x. All right. G and H are you have to be very careful here, especially when you have an exponent of 2. Okay. So here I have f of, what letter is this? G? F of x plus 2. This f of x plus 2 is different than f of x plus f of 2. Function notation is not distributive. So this isn't the same as doing f of x plus f of 2. This is f of the expression x plus 2. That means I'm going to replace x with x plus 2. So I'm going to square x plus 2 and then double it. And then I'm going to subtract 5 times x plus 2. So there's a shortcut of squaring a binomial. If you don't know the shortcut, then that's just simply x plus 2 times x plus 2. When you're squaring something, what do you do? Like when I square 3, what's the process? What do I do when I square 3? Y'all know how to do that. Tell me what it is. I ask for simple things and people go blank-eyed on me. I ask for more complicated things and people respond real quickly. That's just the nature of the business. Because people think it can't be that simple, and sometimes it is that simple. What happens when I square 3? 3 squared, what happens? What am I doing with the 3?
3 multiplies by itself.
Yeah, 3
3
times 3.
Yeah.
So when I square the expression x plus 2, that means I'm multiplying x plus 2 times x plus 2. So now I just use the distributive, I use the whatever method you use of multiplying two binomials. Most people call it the FOIL method. I call it the arrow method, where everything in, so do x times x, and then x times 2, and then 2 times x and 2 times 2. What ends up happening is I get x squared plus 4x plus 4. Okay. The shortcut, because this gives me x squared plus 2x plus 2x plus 4, which is x squared plus 4x plus 4. Same thing I had over here by doing the shortcut. The shortcut is you square the first term, x squared. I multiply the two terms together, 2x, and double it, 2x times 2, which is 4x. And then I square the last term, 4. The reason I double the product of the two terms, 2 times 2 is 2x, is because I have 2 of those. I have 2x and 2x, so I have 2 times 2x. So it's always doubled the product of the middle terms. And that's pretty much how I multiply, how I square binomials, is using this. I used to use this method all the time, but this has become quicker and easier for me. And now I just multiply in by the -5. I multiply by the sign with the number. So I get a negative 5x plus, not plus, minus 10. And now the next thing to do is multiply in by this 2. So now this becomes 2x squared plus 8x plus 8. And now I go through, and then I have I forgot the minus 5x minus 10. And now I go through and combine like terms. I have an x term. I have 2x terms. One's 8x and the other is minus 5x. So those, the x squared, there's only one of those. So that just stays 2x squared. The 2x terms combine to a positive 3x, because 8 minus 5 is 3. And then the plus 8 and the minus 10 are, we call them constants because they don't change no matter what x is. The plus 8 and the minus 10 stay plus 8 or minus 10, but I combine them because they're like terms, and so that's a -2. Boom, done. Now, letter H. There's a thing called the difference quotient. The difference quotient deals with f of x plus h. We're going to do the same process we did here and simplify as much as we can. But with f of x plus h, you will see that there's no combining of like terms. But we'll discover that in a second. So we have f of x plus h, which means instead of x, I write x plus h inside parentheses. And now I simplify. I square the binomial. And so that's going to be 2 times the trinomial, x squared plus 2xh. I did it again. I did that last time. Xh plus h squared. And over here, I'm going to multiply in. I'm going to multiply in by this -5. So that's a minus 5x minus 5h. Right? To get this expression here, this trinomial, I squared the x. I multiplied the x and the h and doubled it. And then I squared the h. And now the next thing to do is multiply in by 2. And we get 2x squared plus 4xh plus 2h squared minus 5x minus 5h. Please realize that well, a lot of y'all may have discovered by now or already know about it, is that a lot of what we do in mathematics is tedious work. Tedious work by you're writing the same thing over and over again. Okay. And that's where mistakes come in, because it's boring and you're not paying much attention because it's boring. And you're just doing what you can because it's boring. Well, because it's boring, your mind goes numb and blank. And so that's where you start writing things down incorrectly. Please be aware I do the same thing sometimes, or I get ahead of myself. I'm trying to do this and I get going so fast, or my mind is ahead of it. I get ahead of myself. I do that a lot. Like I think I did that here where I tried to write h, just h instead of the x plus, because I got ahead of myself and I said, well, I'm going to write h, so I wrote an h. And so anyway. But there's no like terms to combine. There's only one term that has x squared. There's only one term that has xh. There's only one h squared term. There's only one x term, and there's only one h term. So there's nothing to combine. So this is my this is what f of x plus h looks like. Any questions? Yeah, and then they go ahead and go through it and they get the same numbers we got. Oh, I like it that they say the image of 2 is -2. Yeah, when I put 2 in the, oops, here we go. When I put 2 into the function, I got -2. So the image of 2 was -2. Or an argument of 2 gives us the image of -2. All right, and then this one, letter B, multiply the, and then letter C was multiplying the equation by the function by 2. And then putting negative x in for x. We ended up changing the sign on the odd degreed term. And this one, we're changing all our signs because we're negating the function. Right, instead of squaring x, we're squaring 2x instead of multiplying x by -5, we're multiplying 2x by -5. And then the substituting here. Yeah, the ones that people have the most difficulties with, let me back up to the full screen up here, are like letter D, G, and H are the ones people have the most difficulty with. F also throws people into a tizzy, letter F. But it's when you're putting something other than just X in there. When you start putting other variables in there, sometimes they may ask you want to say, what is f of t? Well, I'm just replacing x with t is all I'm doing. So I'm rewriting the function in as a function of t instead of as a function of f. Or I could do f of t plus 9. So I'm rewriting the function as a function of f, but now it's a function of t plus 9. Or and once you simplify it, it becomes a function of t. So that we have those issues and those things going on. Okay. Parametric equations, you substitute some function of t in for x. You do that in vector analysis and in differential equations. We do a little bit of it in the calculuses. Well, vector analysis is calculus 4. Yeah. Okay. So we did that. This one is very important. F of x plus h, because when we get to the difference quotient, which is part of this section, we will be doing this. We will find out what f of x plus h is. And then we're going to subtract the original function, f of x, from it. And then we're going to divide that result by h. And we'll get to that. But understanding how to do this is very important. All right, and this is just using a calculator to evaluate values. So you punch the function into the calculator, and then you how are they doing it? I never really looked at this because I just kind of jumped right over it. Oh. Yeah, if you notice here, they do this. Y sub 1 equals, so and because they're using a TI a graphing calculator, and the way you get that on oh, I do have the way to get the Y sub 1 on the main screen is, if you notice, where is it? You know, I haven't used that functionality, so I have no idea how to put that on there. Has to do with, is it with stat? No. Is it with list? Let's see. No. There's a way to put Y sub 1 up there. I used to know all the bells and whistles on this machine, but I use it so seldom now. Anyway, I got a lot of calculators, more than I need to have. And then f of 1 over x. They're finding what f of 1 over 5.678. So I either type it into the calculator and do that number squared or 1 over that number. Okay, and square root of x. So I find out what the square root of that number is. Yeah, you can do all kinds of things. And that's just using the calculator. And I don't test on using the calculator. So that's why I don't need you to have a graphing calculator. The scientific calculator is all you really need for this course, for me anyway. In any class I teach, the scientific calculator is all you need. When you do graphing, and you will do graphing in this class, I want it to be a pencil and paper, because I need to see how you're doing it and how you're coming up with the numbers that you put there, not just typing the formula into the machine and having the machine tell you what it is. Because that's a different skill set, and it doesn't help you learn things and understand what's happening with functions. In general, when a function is defined by an equation in x and y, we say the function is given implicitly. What do they mean? What do they mean by a function in x and y? Well, that's like if I have 3x plus 2y equals 6. That's a linear function, and it's described x implicitly because I don't know what it looks like y equals, so I can't write it as f of x equals. This is an implicit where this is an explicit. Okay. So we talk about the implicit form versus the explicit form. 99% of the functions you will deal with are the explicit form. Sometimes you will deal with the implicit form, especially when we're dealing with systems of equations. System of equations is very often given this way. As opposed to the traditional way of writing a linear equation in y equals format. Okay. And if it was 3 variables, it'd be z equals, where you have z equals some function of x and y. Yeah, this is very real notation, x, y. So that means you have something like 2y minus 3x. This is our z value, and we're talking about a ordered triplet. And it's 3-dimensional because you have 3 variables. So we're talking about 3-dimensional space. And we do solving systems of linear equations of 3 variables, but we use matrices to solve them. And I really enjoy that. Okay, the implicit form is where when usually x and y are on the same side of the equal sign. Explicit form is where it's y equals some function of x. And so these are 3 examples of that. Okay. And to get it in the form of y, you just simply solve for y. Okay. Now, each x in the domain, for each x in the domain, there is exactly one image of f of x in the range. That's just straight from the definition, right? Each x value is paired with exactly one y value. So each member of the domain is paired with exactly one image in the range. It is saying the exact same thing, just different words. More than one x in the domain can have the same image in the range. It's like with x squared. I use x squared all the time as this example because 2 squared and negative 2 squared equal the same number. Negative 1 squared is the same thing as 1 being squared. Okay, the symbol F, and sometimes, we can use other symbols, not just F, is the symbol we use to denote the function. It is symbolic of the equation or rule that we use to get x from the domain into the range. Next step. All right. If y equals f of x, then x is the independent variable and y is the dependent variable. It's also known as the value of f at x. Okay. It's also known as x is also known as the argument of f, or whatever expression we put inside those parentheses there is the argument of f. If I put a number 2 in there, then 2 is the argument of f. So that means we're going to operate the function on the number 2. If I put in x plus 3, then the argument is x plus 3, and we do the function on x plus 3. Now, here's the difference quotient. What fun, what joy, right? You'll find out why I said it that way. Please note that h can't be 0. Well, because what happens when you divide by 0? Punch it in your calculator and see what it says. It won't give you a value. It'll say error or something. The fancier calculators will say undefined or something like that. So this is the difference quotient. F of x plus h. Oh, I didn't say this in the other class. When you have this on the test, notice I said when, not if. I will ask you to evaluate this or find out what its difference quotient is. I'll give you a function and ask you what the difference quotient is. I won't ask you to remember what this quotient, this formula. I will put this formula on the test in the question. So you won't have to remember this. This is not, I don't ask you to memorize this. You're going to have to in calculus, but at this point in the game, I don't ask you to remember it. Because once you deal with this problem on exam 1, you won't see this again from me. Unless you take calculus 1 from me, which I haven't been, I've only taught calculus 1 at SAC, so they probably won't give it to me here because there's too many full-timers who want to teach it. Yeah. All right. Now, how do we use this? Well, my f of x is x squared minus 1. and I want to find the difference quotient of this of this function. That means I'm going to have to find out what f of x plus h is. All right, to find out what that is, that means I'm going to have to put x plus h in place of x squared. So this becomes x plus h squared minus 1. I go through the process of squaring that binomial, which gives me x squared plus 2xh plus h squared. And then I have the minus 1. Now I'm going to put it into this formula. So this, I'm going to replace this in the formula with this expression. So this becomes x squared plus 2xh plus h. What the hell? Plus h squared minus 1. All right, that's f of x minus f of x. Well, I'm subtracting the entire function. So the entire function needs to be inside parentheses because I'm subtracting everything here. I'm subtracting the x squared and the minus 1. And once I simplify my numerator, I'm going to divide by h. And now I start simplifying. I start simplifying by getting rid of these parentheses. That means I'm subtracting both of these things in here. In effect, I'm multiplying in by a -1. So now I have the x squared plus 2xh plus h squared minus 1. All right. Please be aware that this part can get awfully tedious, especially if the expression has more than just x squared and a constant. What if it had x squared plus 3x minus 1? All right, then you'd have to do 3 times the 3x, 3 times the x plus h. And so now I'm going to do minus x squared, which is minus x squared, and then minus a minus 1, which is plus 1. Because multiplying positive times a negative, a negative times a positive is a negative, and negative times negative is positive. And I'm still dividing by h. Having graph paper to do this on is just helps me with keeping things going in a linear path rather than I tend to go up or go down when I'm writing things. And so having a path laid out before me makes it easier. Okay. So now I go through and I look for like terms. Here I do have like terms. I have x squared and I have minus x squared. And x squared minus x squared goes to 0. They cancel out. Here I have minus 1 and I have a plus 1. Minus 1 plus 1, or 1 minus 1, is 0 again, so they cancel out. The xh and the h squared are different terms, so there's no combining there. And so everything left behind in the numerator has an h in it. So I have 2xh plus h squared, I didn't need that long a line, divided by h. Now I notice I have h in both terms in my numerator, and I have an h in the denominator, so I'm going to factor my h out of each term in the numerator, and I'm still dividing by the h in the denominator, right? Because I factor h out of this, out of 2xh, that just becomes 2x. I factor 1h out of h squared, that just leaves me h. Or I could have done it this way and said that this is two fractions being added together with the same denominator, and the numerators were different. So 2h divided by h equals, plus the h squared divided by h. I do a verified form of this in my head. And it turns out that these two h's go to 1, so that, and over here, this h goes away with this h, and so that's just 1 there, multiplying by 1, and this h goes away with one of these h's up here, so it just leaves h up there. So in either case, I'm left with the expression 2x plus h. And if I take the limit of this expression and see what happens as h goes to 0, that gives me the derivative of x squared minus 1, which is 2x. But if you take calculus, that's one of the that's the guiding principle behind that's the limit definition of the derivatives. Okay, questions? No questions?
When will this recording be uploaded? Just so I can review this again.
It will be uploaded. Hopefully today.
Like I got it. I just want to like quickly review it again later.
Yeah, I understand. Yeah. And the best way to learn this is to do it. Find simple equations and find the difference quotient of it. And if you have any questions about it, either email me or contact me. I'm gonna start doing office hours, and on Monday, Wednesday, since I'm teaching all morning long, from 3:30 to 4:30, I will have a Zoom open, and I'll be sitting here doing whatever work I need to be doing. And you just pop into that Zoom if you have questions, or you want to like if you're practicing this, come in and see if you're doing it right. Okay. Yeah, so one of the differences between how they do it and how I do it is I used to do it the way they're doing it here, which means where I figured out where f of x plus h is first before I put it into the formula. So this over here is what they're going to figure out here. See, and then they do the minus of this one and got that. So at this point, this is what I have here, right? This part here is what I have here. And then they go through and combine like terms. And then the textbook factors out the h and the numerator, and then reduces the fraction from there. Okay, but I kind of do this in my head because each of these have an h, so I can divide each one of these by h, and that's kind of how I do it. Of course, I play with numbers all the time, so, and I like doing this kind of crap. So now 1 over x. Okay. Oh, I'm not gonna. So we find f of x is 1 over x. So f of x plus h is 1 over x plus h. Realize that once I get my math lab up and they throw different quotients at you, some of the functions will be more complicated than what I've done here. So if you're having issues with those, do not hesitate to email me or ask your professor or ask the instructor or something like that. Okay. So yeah, it's pretty straightforward. So we have f of x plus h, which is x 1 over x plus h, minus f of x, which is 1 over x, being divided by h. Now, how the textbook does it, they simplify the numerator into one fraction and then deal with the fact that we have a fraction inside a fraction. What I like to do, I like to find out what the common denominator is here in all the parts. So I have 3 terms in this. This is called the complex fraction because we have a fraction inside a fraction. All right. The common denominator here happens to be multiplying these 2 denominators together. So x times x plus h. If I multiply the numerator and denominator of the large fraction by the same thing, then I'm multiplying by 1. I'm going to change what this looks like, but not how much it is. So what happens here is I'm going to multiply both the terms up here by x times x plus h, and I'm multiplying the denominator by the same thing. Please notice I did not multiply in by the x. We want to leave everything factored until we can simplify things. Okay, so right now we're just going to leave it this way. So that means this numerator here becomes x times x plus h. And we have x plus h in the denominator. Subtracting, and now 1 times it gives us x times x plus h being divided by x. And then we're still dividing by h, and we multiply the 2 denominators together. So this becomes xh times x plus h. Typically, I would write this as hx, but the h is going to end up going away, so I leave it that way. Now, up here, I notice I have x plus h in the denominator and x plus h in the numerator, so those are like factors, so those go to 1. Here I have x in the numerator and x in the denominator, so these go to 1. So my numerator just becomes x minus the expression. Notice those are in parentheses, so it's going to I'm subtracting parentheses x plus h. And I'm still the numerator hasn't changed. H times x plus h. Now to simplify the numerator, to get rid of these parentheses, I'm changing my signs in there. I'm multiplying by -1. So I have x minus x plus minus h, because all those signs change. And I'm still dividing by hx times x plus h. X minus x is 0, so boom, those are gone. So now I'm left with a negative h being divided by hx times x plus h. The 2 h's go to 1. And so I'm left with a 1 in the numerator. So I have a -1 divided by x times x plus h. Please notice I still haven't used the distributive property and multiply in by the x or the h inside. I'm going to leave this factored down here. So we don't need to multiply it out. Okay. Now, notice the negative sign in the numerator. We don't want that. So it's going to migrate out to the front. So it's going to be a negative 1 divide. It's going to be the negative of 1 divided by x times x plus h. Now, there's a reason why we do this. Well, I will always do this. I don't know if I don't think my lab requires you to do that, but I know there's professors who will require it. A negative 2/3 is the same as the negative 2 over 3 is the same as 2 over negative 3, which is the same as a negative 2/3. They equal the same amount, but semantically, they are different things. These first two are you're dividing a positive and negative number. The third one is a negative number. This is an action. This is an action. This is a number. This is negative 2 being divided by 3. This is 2 being divided by negative 3. This is just a negative 2/3. It's just a negative number. Yeah, you're thinking in your head, no, they're the same thing. No, they're not. They're different things, but they equal the same amount. Okay, it's like 0.75 and 3/4. They equal the same amount, but they're different things. One's a fraction, one's a decimal. The actions are different. How they're represented is different. It's like saying 12/16 is a different thing than 3/4, but they equal the same amount. This is 12 particles that have been divided into 16 equal pieces, where this is only 3 things of 4 equal sizes. This is 3 things of 4 things that are 4 equal sizes, and they just happen to add up to be the same size. Okay. So yeah, mathematicians are a little nutso that way, a little anal retentive in that manner. But me personally, I will almost always write it this way. But the answers I accept are any one of these. So whether you come up with the answer and leave it this way, or you go to that extra step and write it this way, I don't care. But just be aware that there are professors out there who this is the only way to write it. A negative fraction is written this way, not this way, not this way. Very good friend of mine who I went to UTSA with was one of the reasons why I did so well at UTSA. She says, this is the way they have to write the answer. For her. For me, I don't care. Because for me, it's about the process. How did you get there? Now, later on, if you wind up in a situation where you need to be very careful where that negative sign winds up, yeah, that's when you start worrying about what the differences are of these things. But for my math class, yeah. Okay. Off of that soapbox. So they did it, and yeah, this is a difference between how the textbook does it and how I do it. What they did here was they dealt with this by combining these, by multiplying both by the common denominator, and then wrote it as one fraction. And now they multiply both numerator and denominator by that same common denominator, and wind up with the same thing I have here. Except here they went ahead and They combined two steps. They multiplied by the common denominator and they did the distributive property with the minus sign. Please realize that MyLab does that. They'll combine steps where I typically do not. Sometimes I do, but for the most part, I don't. If I do and you don't understand what was going on there, please let me know and I'll go ahead and do it. Because I don't want you confused. Yeah, and they went ahead and did it this way, writing the negative sign out front. But I think MyLab doesn't care whether if you left the negative sign upstairs or put it out front. But I don't think they ever write it with the negative sign in the denominator. I don't think they allow for that. Okay. Yeah, square roots. Square roots are fun. No, they're not. Yes, they are. So when f of x is the square root of x, so that means, whoops, f of x is 2 times the square root of x, then that means f of x plus h is going to be 2 times the square root of x plus h. And yes, I see that it's not in the view. Here we go. And so that means my difference quotient becomes 2 times the square root of x plus h minus 2 times the square root of x being divided by h. So far, is everybody with me? This is the easy part. Because square roots have certain properties that we can use so we can get rid of it and simplify the numerator. I'll still wind up with square roots in the denominator, but I won't have any in the numerator. So I can combine like terms and get rid of things. And what the textbook doesn't do is they don't factor this 2 out because we're going to be able to do that. Now, there's something known as a conjugate of square roots. All right. If we have, I'm going to do some work down here that I'm going to erase. So please be aware of that. If you have the square root of a minus the square root of b, if I multiply this by the square root of a plus the square root of b, something magical happens here, because this deals with the product of a sum and a difference of the same two terms. If I have x minus y times x plus y, then this becomes x squared minus y squared. The product of the sum and difference of the same two terms results in the difference of two squares. So that means I'm going to square the square root of a, and from that I'm going to subtract the square root of b being squared. All right. What happens here when you end up doing the binomial multiplication, your two middle terms end up subtracting each other out. So you get xy minus xy. Right. So that's why there's no middle term. And that's why there's no middle term, because you have a square root of a times square root of b minus the square root of a times the square root of b, which is the square root of ab minus the square root of ab. Okay. So that's what we're going to do up here. I'm going to write this exact same expression, but with a plus sign in between. So it's going to be 2 times the square root of x plus h minus 2 times the square root, plus 2 times the square root of x being divided by 2 times the square root of x plus h plus 2 times the square root of x. Now, why did I do that? Why do I write it as a fraction this way? Anybody tell me?
Because whatever you do to the numerator, you have to do it to the denominator.
Exactly. What does this fraction equal? This fraction right here?
1.
1. I'm multiplying by 1. It doesn't change how much it is. It just changes what it looks like. All right. That's like changing 1/2 to 3/6 by multiplying numerator and denominator by 3. So I'm multiplying by 3/3, which is 1. I just multiply by 1. It's still 1/2. It just looks different now. Okay. So I'm going to multiply the numerator by this numerator, and I'm going to multiply h by this denominator. I'm going to do the denominator first because I'm not going to use the distributive property. So now I have 2 times the square root of x plus h plus 2 times the square root of x in the denominator. I always forget to close my parentheses. Now in the numerator, I'm going to have the 2 square roots of x plus h is going to be squared, right? Because I'm going to square the first term, and I'm going to subtract squaring the second term, the 2 square roots of x squared. All right. Since this 2 is inside the parentheses with the square root, I'm going to square that 2 as well. So this term in my numerator becomes 4 times x plus h, because the square root of x plus h being squared just gets rid of the square root symbol, and I'm still multiplying by 4. Minus, let me write this line here. And now I'm going to square 2 times the square root of x. So I'm going to square the 2, which is 4, and I'm going to square the square root of x, which is x. And it's still going to be divided by h times 2 times the square root of x plus h plus 2 times the square root of x almost forgot the close parentheses again. I do the distributive property in the numerator. So that's going to be 4x plus 4h minus 4x. Whenever I hear 4h, I think of the organization, the 4-H club. Taught high school for 19 years, and every school I taught at, except for one, had a 4-H club. High school I went to had a 4-H club. I also had a rodeo club. You know, one of my good friends, used to ride bulls. His father would get pissed at him, tell him to leave his bulls alone because he would make his bulls unmanageable by trying to ride them all the time. Okay. Yeah, he was a hysterical person. He was a hoot. A short little kid, barely 5'2", maybe. His girlfriend was almost as tall as I am, 5'10", 5'9". Yeah. Okay, so now we have this situation. We have like terms in the numerator. So the 4x and the minus 4x, and those magically go away, and we expect that to happen. So in the numerator, all I have is 4h. And denominator, I have h times the expression 2 square roots of x plus h plus 2 square roots of x. The h's, they go to 1 because h over h is 1. So in my, yeah, it is a plus 4. Okay. My numerator is 4 and my denominator is 2 times the square root of x plus h plus 2 times the square root of x. Now, looking at this, guess what? My denominator has, my two things in the denominator have 2 as a factor, so I can divide those out because 2 is a factor of 4. So I have 2 times 2 in the numerator because 2 times 2 is 4, so I can write it that way. And then I have 2 times the expression, the square root of x plus h plus the square root of x. And this is the 2's. This 2 goes away with one of those 2 because they equal 1. They go to 1. And I also refer to this as removing my 1's. And so now we have 2 in the numerator, and in the denominator, we have the square root of x plus h plus the square root of x. This is the simplified form. The textbook on the slides only went to this. If you stop here, then it's a minus 2 points. Okay, this would be a 10-point problem. And if you don't reduce your fractions, it's a minus 2 automatically. I don't look at it as you're working the problem. You may not reduce it because it doesn't need to be reduced until you get to the very end. Because at the very end, you may not be able to reduce, even though you could probably have reduced during the problem. And so here they show multiplying by the conjugate of the numerator and denominator. And so they get this thing here like I got the same thing. And then, yeah, they squared everything. And then they simplified. They multiplied in by the 4 and then took out the 0. And they leave it this way. And they take out the h's. And so, boom. We still have an h in the denominator, but it doesn't matter because it's going to be added to whatever x is. And at this point, we say x can't be 0. And we be cool. We use h, but typically h is actually delta x. It's a change in x. X plus delta x. Well, I didn't discuss this in the other class, but f of x is y. And so f of x plus h is another y that goes with a different x. So I could say that that x And then we have x sub 1, and then we have x sub 1 plus h. So I could call that x sub 2. And so this gives me y sub 1, and this one gives me y sub 2. Oh, you can't see it. And so I replace my h with x sub 1, my x plus h with x sub 2. And so now I have 2 points, x sub 1, y sub 1, and x sub 2, y sub 2. And so then I have the formula y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Does this look familiar to anybody? Does this formula look familiar? The change in y over the change in x? Delta
Yes.
y? What is it? What do we call that?
This
Yeah, the slope. So the difference quotient is just slope. Because what is h? Well, h is the difference in the x values. Because then we have x sub 2 minus x sub 1. Well, x sub 2 is just x sub 1 plus h minus x sub 1, which is just h. So h down here is the change in the x value. And this is y sub 2, and this is y sub 1. So the numerator is the change in the y values. And that's why when you get into calculus, they don't use the h, they use delta x. I don't know if you're familiar with the Greek letter delta. Delta letter, Greek letter delta means change. You see it in the sciences as well as in mathematics, and even in some of the humanities and economics courses, they use delta to denote change. This is the capital letter delta. The lowercase delta looks like that, sort of almost a curly QD. This usually means some change in the number or some smallness in the number. This usually means a small number, a very small number, very often a microscopically small number. They also use the Greek letter epsilon for small letters. But epsilon is very often larger than delta, lowercase delta. But anyway, you'll when you get to calculus, that will give you headaches there. It did me. Okay. Where are we time-wise? Okay, we're close enough to time. So we'll start talking about the domain of an equation. The domain of functions defined by an equation. So if you have something like y equals 3x squared minus 1 over x, what numbers can I use in that function? Or if I have y equals the square root of 2x minus 3x squared, what numbers can I use in this function? Right, so that tells us our domains. Okay. There's some restrictions what I can take the square root of in real numbers. There's some restrictions on what I can put in the denominator of a fraction. So there's no restrictions on the numbers I can square. So we start looking at those domains. Often the domain of a function is not specified. So we understand that the largest set of numbers for which f of x is a real number we can use. So any real number that works, we use. So it's the largest set of numbers that work in f of x. And I'm going to stop it there. So we'll start on slide 35 next time we meet. Did someone click on the link I posted? I'm going to get out of this. Did someone click on that link over there? Eh? Okay. Did it work? Okay. And the video comes up. Did you go ahead and click the video to see if it works? And the next question is, was it a video of what we did on Monday? It wasn't from a different class, is what I'm asking. Because I'm so paranoid I'm gonna post the wrong video. Okay. Okay. Because all right, y'all are free to go unless you have questions for me. I'll be here and I'll answer any and all questions you have of me within reason.
We don't
Have
have
a good
any
day, sir.
assignments on my math, right?
Yeah, your assignments will be in my lab. The problem is nobody's gotten back with me on my problems with it. And so I this afternoon I couldn't do anything this morning because I had class all morning. But this afternoon I'm gonna be more aggressive to get people to talk to me. I sent out emails yesterday morning and I had a class in the afternoon. By the time my class was done, it was too late in the afternoon to start going after people that way. But I'm going to go after people this afternoon. Try and get that done for y'all because I know y'all need to be able to do the work for you to be prepared for my exams. So, ooh, bright city lights. Okay. Y'all, anybody else have anything else they want to know about or have questions about or comments about? Okay. Xenia?
So right now
What?
we can, right now we cannot do any assignments yet until the.
Yeah, until I get that up there. Yeah. And so that's why I'm going to be very aggressive about it today. I couldn't be as aggressive yesterday. I'm going to start shooting emails left and right today and see if there's a phone number I can call. Piss off whoever I can so they'll help me. So.
All right then. Bye, sir.
All right. Bye-bye. Y'all take care. All right. Pedro, do you go by Pedro or Pete or Peter? I've had Pedros in the past and they all went by different names. Even those who went by their middle name or by a different nickname. So, okay, I'm gonna end class now. Yeah. He went